So our next topic is mass spectrometer. So this is used to separate isotopes, both qualitatively and quantitatively. Isotope separation and identification of masses. Gives both qualitative and quantitative. I mean, how many different types of masses are there, massive elements are there, and what are their masses? Both can be identified. Okay. So the first thing is, what are isotopes?
Same proton,
Same proton number, different neutron number. So, in the presence of electric field, both of them behave in the same manner. Right? Since the charge is constant for all the isotopes, all of them behave similarly in the presence of electric field. So alternative option is to use magnetic field. So isotope contained same charge, different mass. So in the presence of E field, no difference. Since the charge is same for all, electric field cannot distinguish them. So alternative is to go for magnetic field. So what does it do? In the presence of magnetic field, BQE is equal to A square, where if you apply perpendicular magnetic field, the charged particle undergoes circular motion. Okay, so the exact equation is the force experienced with charged particle in the presence of magnetic field is Q times V cross B. All are letters except for charge. So, if velocity and magnetic field are perpendicular, the particle experiences a force perpendicular to both. So, let's say I am taking a charged particle with velocity V and I am applying perpendicular magnetic field. So, the field is into the board. Field is into the board, velocity is downwards. Velocity is downwards. So, what is the result of this cross product? You have to use right hand thumb rule. So, velocity is downwards, field is into the board. So, to calculate the cross product, we have to see the lowest angle starting from first vector to second vector. So, our curl of finger should give us the direction of motion from V to B. V is downwards, B is into that direction. So, we have to extend this downwards further. I mean, to measure the angle, we have to consider either converging pair or diverging pair. Right? So, here at this point, one vector is converging vector, another is diverging vector. So, you cannot measure angle there. So, you have to extend the other vector so that you get, here I am getting a diverging pair. From this point, both vectors are diverging. So, now I have to take the direction of motion from V to B. So, my curl of fingers, so velocity is downwards, magnetic field is in this direction. So, what is the curl of fingers give you? V to B. Which way? Right or left? Right or left? Right. So here what is this? So even if you apply Fleming's left hand rule, your forefinger is the direction of field into the board, central finger current direction, then thumb gives you the direction of force. So it is in this direction. Now, now what do you want? So from this equation, you are trying to estimate the mass of the particle. Mass is given by BQR by V. Now what are constants and what are the variables? B is a constant, the field we are applying there. Q is charge of the particle. All particles have same charge. R. So if mass changes, radius also changes, provided velocity is a constant. So then only we can separate them. Then only if velocity is constant, mass is proportional to radius. So that is the conclusion we can draw from this equation. So we have to ensure the velocity of all the particles remains same. So whatever may be the mass of the isotope element, we have to ensure all particles have got same velocity. So then only we can use this equation to calculate the value of mass. Right? So now we have to make an additional arrangement to fix the velocity of the particles. So for that I am using again perpendicular magnetic field. So the particle will experience a force towards right. So in the presence of magnetic field, particle goes in this direction, and so if I apply an electric field, I am assuming Q is positive. So for positive charge, I have to push the particle towards left. It means what? I should have a negative potential here and a positive potential here. Is that clear? So I am applying again a perpendicular electric field so that I am directed in this direction, E. So it will push the particle towards left, whereas the magnetic field push the particle towards right, if both are equal. So the force by electric field is what? I consider it as E prime, and here the magnetic field is B prime, here it is B. So force due to magnetic field is BQ. So if both are equal, net force is 0. So what happens? EQ is equal to BQ. In other words, V is equal to E by B. So when a particular pair of electric and magnetic fields are applied, a particle with this specific velocity will experience no force. If velocity is higher, a particle will experience more magnetic field, so it will move towards right. Okay. So for that particular velocity value, if this ratio is matching with that velocity, only those particles will experience no force. So I keep a slit here. So at the end of stage 1, I am keeping a slit here, so that only those particles whose ratio of E and B, whose velocity is equal to this ratio of E and B, they will travel straight forward and enter the second stage. So at that level, I am ensuring velocity is constant for all the particles, whatever may be their mass. So this force is independent of their mass. There is no mass involved in that story. So the force applied by magnetic field depends only on particle velocity and its charge. Right? So I am able to select a particular velocity out of all. Whatever may be the mass, velocity is constant for all the particles. Now the particle enters the second stage. What happens? It experiences a circular motion towards right. Now what is the control parameter? Velocity is constant for all, charge is constant for all, magnetic field is also constant for all. If mass changes, radius changes. Right? So, more the mass, more is the radius. And by measuring the radius, I can estimate the mass of the particle. Because the radius of the track is now proportional to mass. So I am able to isolate the particles with different masses and I am able to quantitatively measure their mass. Both are possible. Right? So that's how this mass spectrometer works. It has two stages. The first stage fixes the velocity of the particle. Once you fix the velocity, whatever may be the radius of the particle, radius of the track of the particle will be proportional to mass of the particle. So to apply this rule, we must ensure velocity, we must fix the velocity first. So with that we are able to separate the particles.